Welcome students and welcome to the course of machine design. Today we are going to see an important topic, that is static equivalent load for rolling contact bearing. The static equivalent load may be defined as the static radial load or axial load in case of ball or the rolling bearing, which if applied would cause the same total permanent deformation at the most heavily stressed ball and raise contact at that which occur under the actual concentration of loading. Means if the static load or the axial load is applied on the ball or the roller, it will give the same that total permanent deformation that it gives in the actual concentration of the loading. Means you are not actually giving or putting some load on the uh, bearing or the ball and the roller, but you are only going to calculate without giving actual value. Okay, this is the static equivalent. And the static equivalent radial load, which whose notation is W naught R. For radial or roller bearing, the combined radial and axial or thrust load is given by the two equations. First is W naught R is equal to X naught WR plus Y naught WA. And second, W naught R is equal to WR. Means you are going to equate the two equations, where WR is equal to radial load and WA is equal to axial or the thrust loading. X naught is equal to radial load factor, you may see from the data book, and Y naught is equal to axial or the thrust load factor. The static equivalent radial load for all cylindrical roller bearing is equal to the radial load WR for all cylindrical roller bearing only. Okay, so W naught R will be equal to WR. Next, in the question you may see the type of bearing and whether it is single row bearing or double row bearing. As in the class we had already seen the video and we had already seen the type of bearing. Basically this is a YouTube class, but in live class we had already seen the type of bearings, so you will easily understand the single, whether it is single row bearing or the double row bearing. In the type of bearing, first is radial contact groove ball bearing. It's given in your question that it is radial contact groove ball bearing. So x naught will be 0.60 and y naught is equal to 0.50. And if it is a double row bearing, so x naught and y naught you may see same. Next, if it is the self-aligning ball or the roller bearing and tapered roller bearing, so x naught and y naught is equal to 0.50 and y naught is equal to 0.22 cot theta. The double row bearing is x naught is equal to 1 and y naught is equal to 0.44 cot theta. Next, if it is a angular contact ball bearing and alpha is equal to 15 degree, then and if it is a single row bearing, then x naught is equal to 0.50 and y naught, that is axial or thrust load factor, will be 0.46. And in case of double bearing, means double row bearing, x naught is equal to 1 and y naught is equal to 0.92. You may notice that in all x naught, whether it is single row bearing or whether it is a double row bearing, x naught value is same. For a single row, that is 0.50, 0.50 for different angle, and in the double row bearing, it is 1 for the different angles. Okay. The static equivalent axial or thrust load WOR for the thrust ball or the roller bearing with angle of contact alpha is not equal to 90 under combined radial and axial load is equal to W naught A is equal to 2.3 R 10 alpha plus WA. Okay, so this is the axial or the thrust load static equivalent, and we had seen in the previous page that W naught R is equal to x naught WA plus y naught WR. Next important point is the thrust ball or the roller bearing with alpha is equal to 90 degree can support axial load only, and this is W naught A is equal to WA. Next, we had seen static equivalent. Now you are going to see the dynamic equivalent load for the rolling contact bearing. So the dynamic equivalent load may be defined as the constant stationary radial load radial load or axial load, which if applied for a bearing with rotating inner ring and a stationary outer ring, would give the same life as that which the bearing will attain under actual condition of load and rotation. Okay, same type of definition, means actually you are not going to give load, but in the calculation you assume that it will give the same effect if the load will apply. Next, W is equal to for the dynamic equivalent load of rolling contact bearing. Okay, so W is equal to X into V into WR plus Y into WA. Okay, static equivalent as W naught R, and the dynamic equivalent is W is equal to X into V into WR plus Y into WA. W is equal to dynamic equivalent load and WR is equal to combined constant radial load. Okay. WA is equal to constant axial or thrust load. V is a rotation factor and its value is 1 for all type of bearing when inner race is stationary. Means generally we have to omit V, but if in exam rotation factor is given, then you have to use V value. Okay. Next is data, sub portion of data book that you may going to use in the numerical problem. So as we know, as we had already seen uh, the data book for the static equivalent, you may see the dynamic equivalent for the Dave group ball bearing type of bearing, and its specification is WAC C naught is equal to 0.025 or 0.04 or 0.07. Value of X and Y for WA upon R less than is equal to E will be 1 and 0, and if WA, this is E value, and if WA upon R greater than E, then X and Y value will be vary, that is X will be 0.56 for all and Y value will be 0.5 corresponding 1, 1.2, 1.4, 1.6, 1.8 and 2 and so on. A is equal to 0.22, 0.44, 0.24, 0.27, 0.3. In case of angular contact bearing, and specification is given like this for the single row, 2 row in tandem, 2 row back to back, and a double row. So X naught will be 1 for the WA upon WR is less than E, and 0, 0, 0.55, 0.73 for the value of Y, and so on for the self-aligning bearing, for the spherical roller bearing, for the taper roller bearing. So we will see numerical, then you may able to understand what is or how you are going to apply this equation with the help of data book. Okay, so I am holding my voice here, and in the next video we will see the numerical on the rolling contact bearing, and specifically on the static equivalent and the dynamic equivalent. So in case of any query, please write in the comment section, and in case of any suggestion, please give to me by that mail or in the comment section also. I'll try to improve myself according to your requirement. Okay, so uh, that's all for now. I hope you may understand the things, and if not, please see my next video, and in that video you may able to understand how this equation is going to use for a numerical purpose. Okay, so thank you for watching.